Okay, we're going to talk about the monthly space news. We call it monthly because we do this every time we have a meeting. This is the one covering a little bit more than 1 month because it was the first that we met last time. I'm going to cover a variety of topics today on the Starship test. It's pretty significant, especially in terms of NSS goals of really getting into space, which does imply that the costs come down. This is how they come down.
We split out 2 separate videos for the Starship test. One covers the test itself, with a description of it, the problems encountered, and the upcoming fixes. The second video describes Starship's new stage separation technique. You can find both of these videos on the YouTube channel G Stanley 0. Links are provided at the end of this presentation.
There were some other things going on. There was a lunar lander crash. It was a private company out of Japan that had a lunar lander. It made it within about 80 feet before they lost contact with it, lost control. There is a launch of an explorer in the solar system called JUICE. This is actually out of the European Space Agency with contributions from almost everybody, going to the icy moons of Jupiter, basically all the ones that have oceans underneath the frozen surface. Also, a little bit about the end of the International Space Station's life. We were talking about orbital debris last month, and we ran out of time, so we saved it for this one. And then a little bit of just recent launches into space. The lunar lander, this was kind of a unique milestone because no private company has yet successfully landed on the moon, just on their own with their own money, their own funding. Actually, there was an Israeli company that tried. They failed at that. And this was the next one up. It's a Japanese company, but it's got some participation actually from America as well. The thing is about 2,200 pounds, a little over a ton. So this is not a CubeSat size thing, not that tiny. It was launched on a Falcon 9, proving you can get there. Now, how did they get there? We don't normally think of a mid-sized rocket going to the moon. Well, they're doing a ballistic trajectory. It's a different kind of trajectory. What it is, it takes a whole lot longer. It took them like four months to get there. You don't do that when you're transporting astronauts. You're not going to have enough supplies and that sort of thing. But if you're doing cargo, you have a lot more options open to you. And the word ballistic kind of implies that there's minimal effort expended. Once you launch it, you don't really have to use much other fuel. It's just pretty much, it's like a bullet. It just pretty much goes where it's going to go. They can calculate these trajectories. They work out well because there's not just the Earth and the moon, but even the gravity of the sun. You put it all together, if you send things in the right places with very little effort. That's what's shown on the upper right-hand corner here. You see launching from Earth, it actually shot out way, way past the lunar orbit. That's the yellow circle there. But then it slowly loops back and comes in. They had to make some minor course corrections, but it was not much. And that's sort of the whole point of a trajectory. Then once they're in that orbit, they went to an elliptical one, and then they circularized it to where it is right now. And then they were going to land from that point. And so all that was working. This thing was launched back in December. So it arrived at the moon in March, and then for another month it went along, making the orbit more circular. And they were finally deciding, okay, now they're going to go and land. They're actually going to land this thing. It had some payloads that were interesting. One was a rover. This is put up by the United Arab Emirates, and that's shown down here in the lower right-hand side. I've showed this one before. Give you a feel for the scale of the thing. You can see there's some people looking at it, and then that's the lander in the middle here. On the right-hand side is the actual rover, and it's like the size of this lecture kind of a thing. A picture on the left is just another picture of what that lander looked like. They were landing. It was going really well. At 80 meters, 240 feet above the moon, they lost contact. They're going 30 kilometers an hour, not much. They had 30 seconds to go, and they lost contact. But right before that, they realized that what had happened was they probably ran out of fuel. And maybe the reason they ran out of fuel is they had some combination of their altimeter and the software that analyzed the results. Something went wrong there. Because maybe they didn't get the right distance. They weren't using the fuel as efficiently as they should have. One way or another, they ran out of fuel in that last 80 meters and crashed. So that's a shame. Okay, moving on. The Icy Moons Explorer, this is the one launched by the ESA, the European Space Agency, is visiting 3 moons of Jupiter, going to Ganymede, Callisto, and Europa. This thing weighs 2.7 tons. It has a huge solar arrays, 85 square meters, because you're pretty far out there. You don't have that much solar power. Usually the really distant probes use radioactive thermal generators. Turns out our stockpile of plutonium that runs those is almost exhausted. So we're not doing many of those anymore. So they're doing solar. It'll get there in many, many years from now, 2031. They have to go through a lot of gravity assist. To get there, I'll just skip ahead here, they actually go out a year from now, they fly by Earth again and just try to catch up with it a little bit. That gives them a little boost on speed. They fly by Venus, do the same thing. They fly by Earth a couple more times. Finally, they make it to Jupiter. That's why it doesn't take so long. Basically, they're going to visit all these moons. They'll pass Io as well, but they're going to visit them all. Finally, they'll go into orbit around Ganymede, and then eventually they'll crash into it. That one, they're not worried about contaminating. Every one of these has a subsurface ocean. There could be life there. That one is so thick, they're just not worried about doing that, and that's why they're crashing there. Ganymede is interesting. It's actually larger than any moon in the solar system. It's the biggest one. It also has a magnetic field, which none of the others do. So there's a lot of interesting things about all these, one way or another. They had trouble. They have a big antenna for their radar, which is kind of key because they were going to actually do ice-penetrating radar looking at the structure down 5.6 miles. Because that's what they want to find out is, how thick is the ice crust? How can we go there? In particular in Europa, they want to do a lander. So they want to get that information. It turned out you need a big antenna to do that, and they had trouble. Only the 12th, just a couple days ago. They did, yeah. They said it was a little tiny pin that got stuck somehow. They had to dislodge it by 1 millimeter. They were doing things to shake it. They rotated it to heat it up and cool it off, the sun hitting it and that sort of thing. They used some kind of device, kind of analogous to explosive nuts or bolts, but it's apparently something that's kind of reusable. They have a way of getting a shock, and they did a couple of those, and that shook it free. So they just did that. I just updated this slide last night. They did it once, and they got one of them out, and they did it again, and they got the other one. So we're in good shape on that. Okay, quick note on just thinking about the space station. What happens at the end? The end is coming. It's the biggest space debris ever is coming up, 462 tons. It turns out everybody has agreed to the end of life in 2030 for the space station. And agreed, I put an asterisk here because that's everybody except Russians. They've only agreed through 2028. And they just did that on April 27th. They said, okay, we'll stick with this through 2028. We need them because they're the ones that do the heavy lifting to adjust the orbit. NASA just recently this year has proposed in their budget building a tug for $1 billion or so. They're saying it's redundancy. Basically, they lack the confidence that the Russians will really stick around long enough to help deorbit the thing. It takes a lot of power to do that. It's controversial because we spend a lot of money to get our stuff up there, all those tons. And then back in the day, that was like $60,000 a kilogram. Even now at $2,000 a kilogram, which is roughly current cost, that's still a little under $1 billion worth of material up there. If you could somehow retrieve that, it might be good. Alternatives that people have proposed, lift it to a higher orbit and make a museum out of it. NASA poo-pooed that one pretty quickly, saying, well, it'd take 30 to 40 of the Russian Progress cargo craft, which supplied the lift power, to do that. That'd be like $6 billion in cost right there. But the real issue is probably the maintenance and the liability for debris damage. Who's going to take responsibility for it? You got all these international partners right now. Probably nobody's willing to take responsibility because sooner or later parts are going to fall off of it. Things are going to happen, and there's going to be debris generated. So I think that's kind of a goner. You could say recycle the parts. There ought to be something you could get. There's solar cells. They're good for like 90 kilowatts. Docking, collars, radiators, instruments. You could probably recycle entire modules. Some of the more exotic things are essentially have an orbiting foundry that essentially melts the metal down and rebuilds it. And there's actually some studies going on to do that. But it's still ultimately who pays, who implements it, and who benefits. So the odds of all that coming together aren't all that good. But if we do have a parts sale, you want to have the garage sale of all time. This is it. You look at that. There's a lot of solar panels out there. Certainly things like airlock, some of that probably is reusable. Some of the newer modules are probably good. The old ones are no good. They've decomposed pretty badly. But a lot of the newer ones, still pretty good. So put your thinking caps on and figure out how could you use some of this stuff. Now, obviously, Axiom and some of the other people that are going to be associated with building new stations, especially Axiom, because they're attaching to the old station. They're probably going to pirate as much stuff away from there as they can, whether they're given permission or not. I mean, who's going to stop them? So there remains to be seen what will happen there. Okay, finally down to how many launches do people think happened since our last meeting, which was April 1st?
35.
Okay. That, you're stabilizing. We had 16. Is the answer. In the interest of time, I think let's just move on. Okay, and you got any questions or comments on these? All right, I think it's time for our main speaker. The warm-up act is over.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a web page and also a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of the National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.